Hello, I'm an ENT doctor, and my father died of vascular dementia about 7 years ago. And I know personally how dementia can be devastating, not for just one human being, but the whole family. And for the past 24 years of my medical career, I've been prescribing hearing aids to elderly ranging from hearing loss, mild cognitive impairment, and dementia. And my ear was able to tell the difference in their voices and the way they speak. Now, this is the birth story of my company. You speak, we listen. With your voice, we make diagnosis. We are Boinosis presenting to you Dementia Golden Time Finder. Now, you all know dementia is a slowly deteriorating disease, and so you often miss the treatment opportunities. And in order to get diagnosed, you need to go to a big hospital, pay expensive costs, and expect only less than 70% of accuracy overall. And who should be managing it? Would it be the patient themselves or the family? We all know the best treatment for all kinds of disease is prevention. The national cohort study shows that early intervention at the first and second stage will decrease the dementia patient increase rate by 67%. But the problem is, at this first stage, the patients have absolutely no symptom, and it's very difficult to convince them to go to the hospital to get any kind of tests, and there's no diagnostic tool actually that exists. So we are going to solve this problem with your voice. Here you see in the blue bar, 69 years old patients reading the same text for the 47 seconds. You can clearly see the different, noticeable difference patterns across the disease. Our unique voice DNA sequencing method will predict and inform you of a dementia in advance by precise analysis of acoustic characteristics of your voice. And our core competence lies in new voice biometric analysis technology. Combined with the medically verified data, we are confident that we have a global and disease expansion solution possible. As a proof of that, with English-trained engine, our engine was able to predict Greek, MCI, and dementia patients with accuracy of 87% and predicted their MMSA score and became the winner of multilingual Alzheimer's disease recognition through spontaneous speech challenge of IEEE ICASP of this year, 2023. Let's briefly look at how our service is run. 2 minutes of your voice reading a text and also describing a picture can give you an index number of the possibility of you are having hearing loss and mild cognitive impairment on a daily basis. And our voice-based service you can be used anytime, any place with high accuracy. It's much cheaper, and it can also be used as a group monitoring of your choice, shared with your professional of your choice or your family. Our target market goes beyond dementia, goes to early prediction of dementia market. As you know, is the biggest market in the health industry. And we also have a customized service models, strategies, catering to B2B, B2C, and B2G model, the marketplaces. And we are going to move from Korean market to Asia market to US market as the company grows. My name is Jung Eun-shin, CEO of Boinosis. I graduated from Seoul National University, trained at Asan Medical Center, did my fellowship at Harvard and Mesan Year in Infirmary in Boston, did my MBA in Korea University, currently working as a professor at ENT department in Konkuk National University. And here are the partners and the hospitals and institutions that share our dream. Now we dream of a dementia-free world, and I dare you to dream with us. Please join Boinosis in giving you the empowerment to enhance your health in the palm of your hand. Thank you.
네, 감사합니다. 바로 질문 받겠습니다. 김수연 이사님.
Yeah, I actually did see your Korean pitch as well, and I was actually very curious. You mentioned that your English model was able to predict dementia levels for Greek speakers. So I was actually curious as to how how applicable it is across languages, or do you need to gather separate data sets for each different language?
Well, this is the case. Okay, the language, it has its own characteristics across the country. But the pathophysiology of developing dementia or the brain, deterioration is universal across the all human race. And I call that as an alpha factor. And that's what we found, the acoustical characteristics of your voice, not linguist. No text required. Do you understand? So when you hear something and the brain thinks and then brain remembers and then brain recompositions the words and trying to speak out using your voice, your vocal cord and your lips, everything. The brain uses so many areas of their functions in all these process. When we are testing, we're not just looking at your voice, actually. We are looking at your cognition, the way you speak, the way you produce the sound, and all sort of thing. And that really can kind of mirror how the brain functioning is, actually. So that ARPA factor combined with the language. For example, like Japanese, we're doing that. Japanese language, or 500 people of normal Japanese, 50 normal Japanese language speaking people, and then we pick out the language characteristics. Combined with our ARPA factor engine, boom, you have the dementia prediction engine for that specific language.
Got it. Just a quick follow-up. How important is the device in question? Because everyone uses different phones, right? So how important is the actual equipment that the patient is using?
That's a very good question, because a lot of companies that are similar to us, they go after the disease. But because I'm an ENT doctor and I knew about acoustic characteristics of the voice is so important, I looked at the acoustic different tools. So when I gathered the original data, the very original data from the patients, I use iPhones, I use Galaxy phones, I use tablets, and I use what I call a nude mic, where it detects from 50 hertz to 16K hertz without any kind of disruption at all. So I use all different mechanisms all these different equipment at the same time, and then we have automatically seen what kind of voice informations were lost, from device to device, compared to the nude mic. So that's
네.
how we develop our AI data, voice data.